So the change in enthalpy depends on the amount of stuff. So if the reaction changes, delta H also changes. So if you take your chemical equation, here we've got A plus 2B making C. You can say, well, delta H is something. Here, I'm doubling it. If I double the amount of reactant, I'm going to get double the energy change, right? So if I double the coefficients, I have to double delta H. If a chemical equation is reversed, then you change the sign on delta H. So in the forward reaction, this is delta H. If I run this backwards, delta H is the same value, but opposite in direction. This is the buying-selling business again, right? So it's the same number, I just change the sign. And then Hess's law. If a chemical equation can be expressed as the sum of a series of steps, then the delta H for the overall reaction is the sum of the heats of reaction for each step. So I'm still interested in this A plus 2B goes to 2D, but I'm doing it in two steps. First, A plus 2B makes C, and then C breaks apart into 2D. So I can look at the change in energy for the first reaction and the change for the second reaction, and if I add them together, I'll get the overall. Because when I add these equations together, the C's cancel out, right? And so I add the two equations together, I get the equation I want. That means I add the delta H's together to get the delta H that I want. So why do we care about that? That allows us to determine delta H for a reaction without actually measuring it in the lab, because that might be difficult or even impossible to do that particular reaction. But if we can find some other reactions where delta H is known, and there are books full of them because other people have spent a lot of time, well, let's find delta H for this reaction, and let's find delta H for that reaction. So we've got all this information. If you can find any combination of reactions with known delta H that you can add together to get the reaction you want, that's going to give you delta H for that reaction. Now, is it going to be super precise and exactly correct? No, but it's going to be close. So the example, here's a simple one, and then we'll do one that's a little more involved. So 2A plus B makes C, and delta H is 122. And so they're asking, what is delta H for 2C goes to 4A and 2B? So we have to ask ourselves, what's different about this reaction compared to that reaction? How could we manipulate this one to get that one? What's the most obvious thing? It's reversed, right? So we took 2A plus B and reverse it. C goes to 2A plus B. So for that reaction, delta H then is minus 122 joules. Right? It went the other direction. And then what do I need to do to this to make it into that? Multiply by 2, right? So times 2, I'm going to get 2C to 4A and 2B. So that's saying twice as much stuff reacted. So then the delta H is 2 times negative 122 joules, or minus 144. Yeah, you're paying attention, and I apparently am not. Is that better? The 122 times 2 is 244. So the answer is B. I think I do need another nap, but apparently I haven't had enough Rockstar either. And it's only halfway through the semester.
This is the worst part.
Is it?
Yeah.
Any questions? Other than involving my, personal health and well-being. Okay, let's do this one. Find delta H for this reaction, and we're given these 3 reactions with known delta H's. The nice thing about this, we've got a theme going on here of looking at the bright side. So yes, this is a lot of manipulating of equations and stuff and detailed things. The good news is we handed you the 3 reactions that you need on a silver platter or a silver screen, right? You don't have to go looking through a book to find them, not knowing, well, is this the one I need? Is this the one I need? So that's better, right? So we have to figure out how we can take these 3 chemical reactions and add them together to get this one. So some of you are going to find this fun, and some of you are going to find this incredibly frustrating.